My topic I chose this semester are kaleidoscopes. Kaleidoscopes are usually toys for children that produce changing patterns of colors and shapes that are visible through an eye hole when the objects in the kaleidoscope are rotated. The patterns are created by mirrors that are located inside the kaleidoscope. There can be 2 or more mirrors arranged in a kaleidoscope. How the mirrors are positioned to each other determine the number of reflections made and what patterns are created. This toy may be simple and fun, but how it works is based on mathematical processes. The main math topic behind how kaleidoscopes work is geometry, along with optical reflections. The more mirrors you add to a kaleidoscope system, the more complex the math and reflections behind it is. Kaleidoscopes that contain 2 or 3 mirrors have the simplest math to understand. The 2-mirror system is the most common system used in kaleidoscopes. In the 2-mirror system, the angle between the 2 mirror surfaces determines the number of reflections that make up that image. It's hard to make this apparatus yourself, so I found this applet that demonstrates how it works. The black line is the 2 mirrors with the angle of the mirrors stated, and then the object is the blue line and yellow circle with orange around it. And then the blue line with just a yellow circle not filled in is the reflection. So if we move this green dot, we can see the number of reflections change as the angle between the mirrors gets smaller. We can come up with an equation that determines the number of reflections based off of that angle. So then we don't have to use this applet or use a physical apparatus to find out the number of images. This is based off of a circle 360 degrees. And so we take that 360 degrees and divide it by the angle between the mirrors and minus 1. And that will give us the number of reflections. We can test this out by saying 360 divided by 60 is 6, and then minus 1 is 5. So if we change the angle to 60, we should see 5 images. One, two, three, four, 5. The 2 that show up there is only counted as 1. And that's how a 2-mirror system works. A 3-mirror system is a little more complicated math, and you have to use some physics because it's based off of where the reflections land. So this is an applet I made that demonstrates this. We see that the triangle represents the mirrors, and they're at a 60, 60, 60 degrees. And we have to determine where the reflections go. So the reflection on the one mirror, the X, we see where they all land depending on which mirror is doing the reflection. Then we have reflections of those reflections, and we have to see where those will land. And that's where what we see here. And finally, we have reflections of those reflections. So a third reflection, and we see that here. And that is the pattern we see when we look through a kaleidoscope. Those are the reflections. That's what makes the pattern. And so if we move dots 1, 2, and 3, we can see a pattern's made. And so if those objects were in a kaleidoscope and we rotated them, we would make a pattern that looks like this, which is kind of fun. And that is what I learned about kaleidoscopes.